Hey everyone, and welcome back to this class, Reinforcement Learning in Python. In this lecture, we are going to discuss some of the applications of what you're about to learn in this section. For a lot of you, this is review from my Bayesian machine learning course, so if you took that course already, you can feel free to skip this lecture. For the rest of you, please listen in. Once in a blue moon, I get someone asking, wow, this is a lot of math. It is very scary math, but how does this apply to the real world? And I get where you're coming from. Although I gave you an example of going to the casino, that seems like a pretty contrived example. In fact, if you went to the casino and you tried to bring your computer to do some of these calculations, you would probably be banned from that casino. So don't try this at home, in other words. Luckily, there are actually many real-world applications of these methods. In fact, this is one of the topics I teach that I can confidently consider one of the most practical algorithms you'll ever learn. So why do I say that? Well, the concept of comparing things to see which one is better, that can be applied to almost any business. Imagine you are Apple. You just created a brand spanking new iPhone, and you want to tell the world about it. You ask your designer to make a couple advertisements for you. So your advertiser shows you these two ads, and you really love them both because your designer is very talented. So which should you choose? Of course, you should choose the advertisement for the iPhone that you believe the user is most likely to click or buy. One possible way to measure this is to determine the click-through rate of each advertisement. Now, how do we determine the click-through rate, or CTR? Well, it's simply the ratio of clicks to the total number of impressions. So for example, if I showed an ad 1,000 times, but only 10 of those times the user clicked on it, then it has a CTR of 1%. So how can I measure the click-through rate in practice? Well, we can do an experiment. Let's say I show the first ad to 1 million users, and I show the second ad to another 1 million users, and then I compare the click-through rates I get from each ad. But there's a problem with that. How do I know 1 million is the correct number? In fact, I don't. Why not show the ad 1,000 times? Why not show the ad just 10 times? Well, here is where you have to remember your study of probability. The only way to have absolute precision in your statistical estimate is to collect an infinite number of samples. As you recall, as you collect more and more samples, the confidence interval of your estimate decreases. So the answer is, collect as many samples as possible. But there's a problem with that too. Keep in mind that if one advertisement is better, that necessarily means the other advertisement is worse. That means the better advertisement will result in more profit, and the other advertisement will yield less profit. So if I show the worst advertisement 1 million times, that means I've wasted 1 million impressions for a suboptimal click-through rate. In other words, my desire to always show only the best advertisement to exploit the optimal click-through rate is fundamentally at odds with my other desire to have an accurate answer for what the click-through rates are in the first place. Now, obviously, Apple is not the only company in the world selling things. The online advertising industry is a billion-dollar industry. Almost every modern business in the world uses online advertising. In other words, the techniques you're learning here are applicable to any of the modern businesses making use of the billion-dollar online advertising industry's platform. However, you don't even have to be a successful business to make use of these techniques. You can simply be someone who owns a website on the internet. Assuming you have traffic and you have a choice between 2 or more options on your website, then you can apply these techniques. For example, suppose you hired a designer to create a new design for your website, and you would like to know if your old design gets better traffic than your new design. Perhaps you would like to know whether a big Buy Now button works better at the top of your sales page or at the bottom of your sales page. Perhaps you would like to know what kind of price ending to use on the products on your website. For example, you could sell your product for $20 flat, or you could sell it for $19.99 or $19.98. Which one is more likely to yield more conversions? Of course, these are all fundamentally the same problem. You want to know which choice is better and to exclusively use the better choice, but you need to collect data in order to make that choice. As a side note, from our perspective, both click-through rates and conversion rates are treated the same, since they are both a form of calculating some generic success rate. Obviously, from a monetary perspective, a click isn't as valuable as a conversion, but for us, we're not necessarily measuring the revenue or profit itself, just the success rate. Another great example is the Facebook newsfeed. And of course, this isn't exclusive to Facebook. This applies to any company that has a newsfeed, like the New York Times. Ideally, you would want to have news articles that people are going to click on or read. And why is that? Well, funny you should ask. You see, when people click on these articles, they see more ads. When they show you an ad, they make money. Thus, it is the circle of life. Advertisers make money from you when you buy things, and websites that show ads make money from the advertisers simply for using that space on their website to put the advertisement. So the New York Times wants you to click on articles, and Facebook wants to keep you engaged, scrolling through the newsfeed for as long as possible. The more you scroll, the more ads you see. Again, what are we doing? We are measuring a success rate. For the New York Times, that means we clicked on the article. For Facebook, that means we read, watched, or somehow engaged with the newsfeed item. Once we've measured the success rate of each newsfeed item, we can show them to users in order with the highest success rate at the top. One thing we're going to look at in this section is using a Gaussian distribution instead of a Bernoulli. If you recall, Bernoullis are for measuring success or failure. They're ideal for the scenario when you only have two outcomes, click or no click, buy or no buy. But what if your reward is a continuous value? In that case, a Gaussian distribution may be more appropriate. Some examples are measuring revenue or profit or the number of users. So I hope this lecture settled this question for you, and you now understand why the explore-exploit dilemma is one of the most, if not the most, practically applicable concept in machine learning. Almost every business and online entrepreneur can make use of these algorithms. Anytime we have a choice, which design, which button, which headline, which post, you can apply these methods.